Multiplying binomials is one of those fundamental skills that they test for on the ACT math exam. So in this video, we are going to do several examples where we multiply binomials. The first example, x plus 3 times x plus 2. We can actually solve this using two different ways. They actually end up being the same method, but one is an acronym called FOIL, which you are probably familiar with, which stands for first, outer, inner, last. So I'm going to write that down, FOIL. And what that means is we take the first terms and multiply them together. So in this case, x times x, so that's x squared. Then we take the two outer terms, so x and 2. So we do plus x times 2, so 2x. Then the inner term, so the 3 and the x, so plus 3x. And then the last terms, 3 and 2, so plus 6. The other way to do this is actually to recognize that really this is just applying the distributive property twice. So distributive property. What that means is you break up that x plus 3 term into an x and a 3. So then you just take it as x times x plus 2 plus 3 times x plus 2. And you'll notice here when we do this, so we get x squared plus 2x plus, and then we get 3x plus 6. You'll notice when we do FOIL or the distributive property, we get the same exact thing. X squared plus 2x plus 3x plus 6, or we can simplify that further, x squared plus 5x plus 6. All right, let's do the second problem, and for this I'll just use the FOIL. So the first terms, so that's 2x times x squared, so that's 2x cubed. We're going to do the outer term, so 2x times negative 1 is negative 2x. Now we're going to do the inner terms, so 3 times x squared is 3x squared, and last, so 3 times negative 1 is negative 3. Most likely on an exam that's multiple choice, they'll put these in order. So 2x cubed plus 3x squared minus 2x minus 3 is likely how the answer would appear on the ACT. What about the bottom left example where we have a binomial times a binomial times a binomial? Let's do the last two binomials first, and then we'll multiply that answer by the first binomial. So again, we're going to use FOIL. So we have 2x times negative x, so that's negative 2x squared. And then outer, so 2x times negative 1, that's just going to be minus 2x. Inner is minus 4x. And last, of course, is minus 4. And of course, we need to remember to keep the x minus 3 out in front. This can simplify a little further to make this easier on us. So that's negative 2x squared minus 6x minus 4. And we multiply that all by x minus 3. All right, so now we have a binomial times a trinomial. So why does this get a little difficult? Well, if we use FOIL, there's no first, outer, inner, last anymore because we have a trinomial. So this is where knowing the distributive property is important. So let's do it this way. So let's take x times negative 2x squared minus 6x minus 4, and then minus 3 times negative 2x squared minus 6x minus 4. And one thing that I noticed about this is actually since we have 3 negative terms on the inside of this trinomial for the second term that's multiplied by 3, we can actually factor out a negative 1. So if we multiply all these by negative 1 and bring that negative 1 out to the front, so we factor it, this is going to become a positive 2x squared, that's going to be a positive 6x, and this is going to be a positive 4. We bring the negative 1 out front, so we multiply negative 3 by negative 1, which just gives us positive 3. This might make it easier to solve. All right, so let's move on and distribute the x and the 3. So this is x times negative 2x squared is negative 2x cubed. Then we have minus 6x squared, and then minus 4x. We're adding to that, so 3 times 2x squared is 6x squared, plus 3 times 6x is 18x, and then 3 times 4 plus 12. Now let's combine all our like terms here. So negative 2x cubed, then we have a minus 6x squared and a plus 6x squared, so that's going to cancel. So we have no x squared term. Minus 4x plus 18x is going to be plus 14x. And then we have the plus 12 at the end. Okay, the last problem is on the bottom right. So in this we have an imaginary number I. If you haven't watched the video on imaginary numbers or complex numbers or different types of numbers, you should probably watch those videos, otherwise this may not make much sense to you. However, for the purposes of this, even if you don't know how to evaluate what I is equal to, we can still multiply these out and do the distributive property or FOIL and almost get the answer, and that'll explain what I and I squared and all that actually is. So let's multiply this out. So we have first terms, so 3 times negative 2x is negative 6x. Outer terms, 3 times negative 2i is negative 6i. The inner terms, I and negative 2x, so that is negative 2ix. And then the last terms is negative 2i times I, so negative 2i squared. Okay, what do I notice immediately here? Well, we can factor out our negative 2. So let's factor out our negative 2 from everything. So now we get negative 2 times 3x plus 3i plus ix plus I squared. And if you're not sure what I is, then this might work. However, on the ACT, I can almost guarantee that I squared will not show up in one of the answers. So the identity for I squared, the imaginary number, I squared is actually equal to negative 1. And I is actually equal to the square root of negative 1. And if you watch the video on imaginary numbers, I'll go through the whole thing on what all this means. But for our purposes, a lot of the times when you get imaginary numbers on the ACT, they'll actually tell you that I squared is equal to negative 1. However, in other questions, they might not give it to you at all. So it's very important that you at least know that I squared is equal to negative 1. Okay, so let's put a negative 1 in for I squared. So that's going to give us negative 2 times 3x plus 3i plus ix, and then, so plus I squared, so plus negative 1 minus 1